Imagine putting the exact same food in front of two people. One person takes a bite and says it's amazing. The other immediately spits it out. Same food, same ingredients, completely different experience. It happens all the time. Some people love coffee. Others think it tastes like burnt dirt. Some people crave blue cheese. Others say it smells like dirty socks. Some people can't get enough of spicy food. Others feel like their mouth is on fire after a single bite. And then there's cilantro, a leafy herb that millions of people enjoy, while millions of others swear tastes exactly like soap. So what's going on? Are some people just picky? Do they have better taste buds? Or does food actually taste different to different people? As strange as it sounds, the answer is yes. The food itself doesn't change, but the way your brain experiences that food can be completely different from the person sitting next to you. And it all starts with something most people never think about: their taste buds. Most people think taste buds are simple. You eat food, you taste food. End of story. But that's not what's actually happening. Every bite of food starts a chain reaction. When food enters your mouth, tiny chemicals from that food dissolve in your saliva. Those chemicals then come into contact with special cells inside your taste buds. Think of taste buds like tiny flavor detectors. Their job is to scan everything you eat and send information to your brain. Scientists generally recognize 5 basic tastes: sweet, salty, sour, bitter, and umami, the savory taste found in foods like meat, cheese, and mushrooms. Your taste buds detect those signals and immediately report what they find. But here's where things get interesting. Not everyone has the same number of taste buds. Some people are born with significantly more than others. Scientists call many of these people supertasters. A supertaster experiences flavors much more intensely than the average person. Sweet foods taste sweeter. Bitter foods taste more bitter. Spicy foods feel more intense. It's like turning the volume knob on flavor all the way up. For some supertasters, foods like broccoli, Brussels sprouts, coffee, and dark chocolate can taste overwhelmingly strong. Meanwhile, other people are on the opposite end of the spectrum. They have fewer taste buds or lower sensitivity. For them, flavors can seem weaker, less intense, less exciting. As a result, they often enjoy stronger seasonings, stronger spices, and more powerful flavors. The exact same food can produce completely different signals depending on who's eating it. Imagine 2 people taking a bite of the same jalapeno. One person's mouth feels like it's on fire. The other barely notices the heat. Same pepper, same bite, different experience. And that means something important. The food itself isn't creating the difference. The person eating it is. But taste buds are only part of the story, because sometimes the biggest difference isn't how many taste buds you have. It's hidden much deeper, inside your DNA. So what does DNA have to do with food? Quite a lot, actually. Remember cilantro? The herb that millions of people happily sprinkle on tacos, burritos, and salads. For some people, cilantro tastes fresh, bright, almost citrus-like. But for others, it tastes absolutely terrible. Not because they dislike herbs, not because they're picky, because to them, cilantro tastes like soap. Scientists have studied this strange phenomenon for years, and it turns out those people aren't imagining it. Inside cilantro are chemicals called aldehydes. Aldehydes are naturally occurring compounds found in many plants. But here's the weird part. Very similar aldehydes are also used in some soaps, detergents, and cleaning products. But some people have genetic variations that make them much more sensitive to detecting them. Their smell receptors pick up those aldehydes much more strongly. As a result, their brain focuses on the soapy chemicals instead of the fresh herbal flavor. So while one person tastes something delicious, another person genuinely experiences something that reminds them of dish soap. Same cilantro, same bite, completely different experience. And cilantro isn't the only example. Scientists have discovered genes that influence how strongly we detect bitterness, how sensitive we are to certain smells, and even which foods we naturally enjoy. In other words, your DNA helps shape the menu your brain creates, before you ever take a bite. But if genes play such a big role, why do people's tastes change over time? Why do kids hate foods that adults often love? And why can someone learn to enjoy a food they once couldn't stand? Because genetics may set the starting point, but they're not the whole story. If your genes help determine what foods you like, why don't your tastes stay the same forever? Most people can think of at least one food they hated as a child but enjoy as an adult. Maybe it was broccoli, coffee, or spicy food. So what changed? The answer starts with something called exposure. The more often your brain encounters a food, the more familiar that food becomes. And your brain tends to trust familiar things. Scientists call this the mere exposure effect. In simple terms, the more you're exposed to something, the more likely you are to like it. This doesn't only happen with food. It happens with music, faces, places, and even smells. The first time you taste a strong or unusual flavor, your brain may react cautiously. But after enough positive experiences, that same flavor can become enjoyable. That's one reason children often dislike foods that adults enjoy. Kids are naturally more sensitive to bitterness than adults. From an evolutionary standpoint, that may have helped protect young children from eating poisonous plants. Many toxic plants taste bitter, so children evolved to be extra cautious. As we get older, that sensitivity gradually decreases, which helps explain why vegetables often become easier to enjoy with age. But exposure isn't the only thing changing your tastes. Your culture shapes them too. The foods you grow up eating become your brain's definition of normal. Someone raised eating spicy food may barely notice heat. Neither person is right or wrong. Their brains simply learned different expectations. In other words, your taste isn't controlled by one thing. It's a combination of genetics, biology, experience, culture, and learning. Which means the foods you love today may not be the foods you love 10 years from now, might someday become your favorites. Because taste isn't fixed, it's constantly evolving. If taste is partly genetic and partly learned, then some foods create a really strange question. Why do people learn to love things that taste bad at first? Think about coffee. The first time many people try it, they don't say, "Wow, that's delicious." They say, "Why does this taste like burnt dirt?" The same thing happens with dark chocolate, spicy food, certain cheeses, olives, and even some alcoholic drinks. Many of these foods are bitter, strong, or overwhelming the first time you try them. Yet millions of people eventually grow to love them. Why? Part of the answer involves something called reward learning. Your brain is constantly connecting experiences with outcomes. Coffee may taste bitter, but it also makes you feel more awake. Over time, your brain starts connecting the flavor with the reward that follows. Eventually, the thing that once seemed unpleasant can become something you actually crave. It's almost like your brain rewrites the meaning of the flavor. The taste doesn't change. Your interpretation of it does. This is one reason adults often enjoy foods that children avoid. Adults have had years of experiences teaching their brains which flavors are worth acquiring. But there's another layer to the story. Sometimes people don't crave foods because they learned to love them. Sometimes their brains are wired to want them from the beginning. And that leads us to one of the most powerful forces shaping human taste: cravings. If you've ever promised yourself you wouldn't eat something and then found yourself eating it anyway, you're not alone. Because cravings aren't just about willpower, they're about survival. For most of human history, food wasn't always available. Our ancestors lived in a world where finding enough calories was a daily challenge. So the human brain evolved to become extremely good at spotting foods that provided the most energy. And three things became especially valuable: sugar, fat, and salt. Sugar provided quick energy, fat provided long-term energy storage, and salt helped regulate critical functions throughout the body. Finding these nutrients increased the chances of survival. So the brain developed powerful reward systems that encouraged us to seek them out. The problem is, your brain evolved for a world that no longer exists. 10,000 years ago, sweet foods were relatively rare. Today, they're everywhere. The same is true for fat and salt. Your brain still responds as if these foods are precious resources, but now they're available 24 hours a day. This creates a mismatch between ancient biology and the modern environment. Scientists sometimes call this an evolutionary mismatch. The brain's reward system is doing exactly what it was designed to do. The environment changed faster than the brain could. And when you eat something rich in sugar, fat, or salt, your brain releases dopamine. Dopamine is often called the brain's reward chemical. But dopamine isn't really about pleasure, it's about motivation. It helps teach your brain, that was important, do that again, which is why cravings can feel so powerful. Your brain isn't trying to sabotage you, it's trying to help you survive, using rules that worked thousands of years ago. But cravings aren't the same for everyone. Some people crave sweets, others crave salty snacks, others barely care about desserts at all. Why? Because just like taste, cravings are influenced by genetics, experience, environment, and learning. And that brings us to one final question. If our tastes and cravings are shaped by all these different forces, can we actually change them? The answer is yes, at least to a point. Scientists have found that repeated exposure can change how people respond to foods. In other words, the more often you experience a flavor, the more familiar it becomes, and familiarity changes perception. This is one reason people often learn to enjoy foods they once hated. Not overnight, but gradually. Your brain starts updating its expectations. The food becomes less strange, less threatening, and sometimes even enjoyable. This doesn't mean you'll suddenly love every food. A person who is genetically sensitive to bitterness may never enjoy certain foods as much as someone who isn't. But most people's tastes are far more flexible than they realize. The same thing is true for cravings. The foods you eat most often help train your brain's reward system. Over time, habits strengthen certain pathways and weaken others, which means your preferences are constantly being shaped by your daily choices. So the next time someone says, "I just don't like that food," they might be right. Or they might simply be meeting an older version of their brain, because taste isn't fixed. It's a combination of biology, experience, learning, culture, and time. And that's why two people can eat the exact same food and experience two completely different worlds of flavor. And that's a fact.